Hey guys, I'm Nick and welcome back to my channel. In this tutorial we will take a look at some sort of a bone erosion with worms or noodles, or it depends on how weird you want this effect to be. But before we start, as always, I would like to say a huge thank you to everyone who supports me by purchasing my project files on Gumroad. And if you want to see more tutorials on this channel, consider supporting me by checking out that link in the description, where you can find dozens of full projects, assets, presets, all of that stuff. Alright, so here we are in Houdini and let's check node by node what do we have here. So we start with some sort of a bone. It can be, I don't know, maybe a skull or like any object you want our worms to eat. So we started with this human femur bone scan from my mini factory. And then I dropped a match size node, target size set to 555, scale to fit is checked, and basically that's how we scale our bone to match in this box of 5, 5, and 5 units. So then I dropped a transform node and rotated that bone so it's some sort of a vertically aligned. It is not perfectly straight, so I wanted to like rotate it a bit here. And then I drop a remesh node because this bone, as you may remember from our previous grain infection tutorial, it had some sort of intersections. So we want to remesh that. Then we drop a VDB from polygons. Voxel size is set to 0.015, and that's how we basically remove all the like broken polygons, all that stuff. Then I convert VDB to polygons, and then I remesh it again so we have a bit denser, uniform, dense mesh. So then we need to specify from which point we want our worms to grow. So we drop a group node and then we plug the remesh into the first input, and into the second input of the group node I plug this sphere, just a regular sphere, but it intersects with the bone here. So if I go into the group, change the group type to points, and check the keep in bounding region enabled and bounding type bounding object, you can see that we target these points here. So then we want to delete everything but not these points, so we drop a delete node, and here in the group we type group 5 because this one is our group 5. It can be anything, but yeah, just type the name of that group, and operation should be delete non-selected and entities should be points. So this is how we delete everything but not that group. This is a mesh and we need just the splines. So we drop an ends node, change the close U to unroll with new points, and it should look like this. So we have our sort of a wireframe here, and then we go into the popnet. So we drop our regular popnet and we are here. This effect, I think it was well described around, I don't know, 2 years ago or something by Entagma, because this is some sort of a very intro thing into sort of a growing or expanding simulations, expanding mesh or expanding splines. I think it's even called like curve grow or something like that. So basically what we are doing here is we are applying force to each point of our wireframe or of our curve, and this force is like a reverse magnet. So basically all the points want to go away from each other. So in our pop source we set the source to be emission type all geometry source use first context geometry, because we have our geometry plugged into our first context or input. And in the burst tab we should set the impulse activation to be $SF, so simulation frame equals 1, so we emit the particles only on the frame 1. And then we drop this pop interact node, and this is what will make them expand or move away from each other. So position force set to 3, and then we drop a pop drag. So air resistance set to 15, just because I don't want them to expand that quickly. Let me remove the multi-solver and sub-solver right now, and let's attach the pop solver to the merge, and let's remove the static object. So I just want to show you what we have here. pop object is default, and in the pop solver, in the collision behavior, we just don't need these hit attributes. Just, yeah. Let's play and see what we got. So here you can see that they are expanding, and if, let's say, popnet rect would be set to 0.5, they would expand much less. And if we set the position for it to be, I don't know, 15, it will most probably crash or something, but they will expand even more. All right, so let's leave it at 3. And for now, let's check this multi-solver and sub-solver setup. We need to drop a multi-solver and attach the pop solver to the left input. And then we drop a sub-solver and attach it to the multi-solver's right input. So here in the sub-solver, all the thing we need to do is to resample, because we don't want these like very rough and straight edges. So in the resample, length is set to 0.03, allow primitive attributes to override parameters is unchecked, and treat polygons as straight edges. I think that's, yeah, that's default. So if we go back to the popnet and then we remove our pop solver from the merge and then attach the multi-solver. So let's see what we have here. You can see that we don't have these rough edges, and overall it looks much smoother than it was before. And basically that's it. We just need to attach the static object, our collider, so our splines are growing inside of our mesh. So what we can do is static object should be always on the left side, and or in this case multi-solver should be on the right side of the merge. And in the static objects, what do we have here? Subpass is set to be remesh 4. It is basically the last node of our bone here. So we go here, and RBD solver set to use volume collisions. Mode volume sample, division method by size. Invert sign should be checked, and proxy volume is our VDB from polygon 3, which is this one. So now, if I check this collision guide, you will see that we have our bone here. All right. So now, I think that's it for this one, and let's play and check how it looks. Yep, looks good. So we have our worms both inside and on the surface. If you want to create sort of a wane growth effect, so it's only on surface, you can go into the sub-solver, select the array SOP, add the file, not the file, but object merge. Here we need our remesh 4, which is our kind of like last node. Obviously, if we would be doing this properly, I would add like a null and call it, I don't know, bone out, not something weird like remesh 4. So sorry about that. But yeah, basically we plug the remesh into the first node of the array, first input of the array node, and object merge into the second. Go into the array, method should be minimum distance. We don't need, I think we don't need the static object actually. So in the subsolver we enable the array, and then let's try and run that. So here you can see that we are now adding them not to the inside, but only on the surface of our bone. So this is how you can grow some veins or something. It's not technically like vein, because veins have more like branches, like a tree branch. Here we are dealing with just a few splines that are constantly growing. So, but yeah, it looks pretty cool though. Let's turn on just the resample, and yeah, you can see that how it feels. Yeah, obviously it doesn't feel anything because we don't have our static object attached, but yeah, now you can see that it feels the inside not only goes on the surface. So yeah, we have our worms. Let's delete our bone from the popnet. We can drop a delete node. Here group should be stream pop source 1, operation delete non-selected, entity points. So we are deleting everything but not our worms here, and we can smooth it out a bit. You can do that, or you maybe don't want to smooth them out. But yeah, anyways, drop the smooth. Then we should add a poly wire, and here in this case they are kind of intersecting with each other, but you can just play with these wire radius and all that stuff. Because we are doing some sort of an organic way, I thought that the intersection is not that much of a problem. Wire radius set to 0.015, maximum joint scale 1, division set to 4. Pretty important thing is to subdivide it a few times, I think. So now they look more like a worm. So then, again, I don't know why I cannot specify the PY in the color if I want to rem from attribute, but basically here in the attribute wrangle, what I do is I set the color to be from 0 to 1, depending on the point position on y-axis. So basically, if I, let's say, go and run this simulation a bit more and now enable the wrangle, you can see how the color changes. So this is also a great example how to use wax for these simple operations, because many of you guys asked how to actually run wax. I think these little expressions or functions are a great way to incorporate in your workflow a bit of wax. Yeah, basically we actually don't need this variable. So basically, yeah, we get the value of p, y, then we remap it to be from 0 to 1, and then we map that value to the color. And I'm exporting that to render in Cinema 4D. You can render it in Blender, you can render that in, I don't know, Houdini. Anyways, yeah, it's just more convenient for me to render it out in C4D. That's why I dropped the ROP Alembic node here. And now I think we are done with the worms part. Let's go and create some bone erosion. So here we are, the frame 52, I think. Yeah, let's move to the 52 just because it will be easier to show. After our remesh, we drop a VDB from polygons. A voxel size is set to be 0.008, and we grab our attribute wrangle and also drop a VDB from polygons. The voxel size of this is set to be 0.005. Then we drop a VDB reshape SDF, offset set to 2. And then we drop a VDB smooth at the SDF, iterations and filter voxel radius as default. And then we drop a VDB SDF subtract and plug the VDB from polygons from the bone to the left input and VDB smooth to the left. And operation set to be SDF difference. And here you can see that we have our sort of a erosion. And then we drop a VDB smooth SDF and iteration set to 2. And then we drop a convert VDB and convert to polygons. And here we have our beautiful erosion. We have some sort of protrusions, holes, and we have all these things here. I mean, I think even without worms, it looks cool. And we can drop a merge and plug our worms and our bone, and here we see how it looks here. So then I export the bone and I export the worms, and now let's open up Cinema 4D and see how I set up the scene. So here we are in Cinema 4D, and you just import, like drag and drop these two, bone and worms. And for the worms, I'm using this sort of a specular material, medium set to be random walk, transmission, light pink color, that I actually then in After Effects I changed to be green, as you may see. So for the bone, it's just like two materials with a bit of dirt. So I want the bone to be here. You can see that, zoom in, you will see that here the bone is a bit lighter than it is. So bone bright and bone, and mixing with the dirt, nothing crazy here. We don't have UVs on the bone, that's why the bone projection is set to box. For the camera, using default thin length camera, a bit of exposure, decrease the gamma a bit. And for the lights, simple 3-point light system. This is our, I think, the fill light, this is our top light, and this is our key light. So that should be it for today, and thanks a lot for watching. I really hope that you learned something new today, and I will be glad to see your take on this effect. If you enjoyed this tutorial, please subscribe to my YouTube channel, leave me a comment, and check out the link in the description for some cool assets, project files, and more. I will be back very soon. Bye!